O- Okay, I answered though. I got took care of that. So okay, so the forward causal disconnect principle is what I just described with experimentally, and direct evidence for the operational role of time symmetric interactions in the quantum electrodynamic amplitude challenges purely classical retarded descriptions and conventional notions of causality. So, microcausality that's asymmetric requires the local observables at space-like separations to commute, which again means like the commutators go to zero, thereby forbidding superluminal signaling and preserving relativistic causality. Um, so this Aronhart-Bohm phase effect that can only be read after the solenoid is turned on. It challenges the conventional interpretation of microcausality because the solenoid is being turned on before there's any possible time due to the distance between the solenoid and the quantum detector for the electron. So there's absolutely no way there can be any kind of classical interaction because of the not just because the electrical field is zero, the classical electrical field, but also that the magnetic the classical potential field is zero as well. So they're saying that this tension is now real between standard quantum electrodynamics and microcausality that demands complete independence between the superluminal signaling and relativistic causality. So there is a interference amplitude, and this is the decoherence from the vacuum fluctuations of the electromagnetic field. So this decomposition physically separates the causal photon exchange from the vacuum stochastic noise, and so there's a distinction that's crucial for understanding how the quantum electrodynamic environments affect the interference phenomenon. So the only way to explain this is that an advanced influence appears to the electron before the solenoid is switched on, which is a manifestation of the time symmetric structure of the quantum electrodynamic amplitude. The phase shift is a global quantum property that can be read only after the solenoid has been switched on. So even though you can only read it after the solenoid has been switched on, due to the time that you're turning on the solenoid and the distance between the solenoid and the quantum detector, it's physically impossible for any classical information to be transmitted. And so this is called the delayed switch Aronhart-Bohm experiment, and it provides a clear test of whether the time symmetric structure or a purely retarded interaction governs the observable phase. So by ruling out the possibility of the retarded interaction, the classical interaction of the solenoid field, even with the potential field, then you're proving that there has to be a future time force that's causing the Aronhart-Bohm effect. Since the observable phase shift depends only on the real part of the effective action it reflects, The fundamental symmetry of the interaction in the real part of the amplitude. So basically, the normal Aronoff-Bohm effect usually means that the phase arises from either an advanced influence of the on the electron or a retarded influence of the electron on the solenoid. The correct interpretation is that both contributions exist and together constitute the total observable phase. So by retarded influence on the electron on the solenoid, what they mean is the time reversed from the future. Both processes are mediated by virtual photons propagating down the light cone, and the time reversed advanced influence and the electron to solenoid retarded influence both remain possible, but in fact are equal. But the retarded influence vanishes due to the space separation between because of the distance between the electron and the solenoid. So I'm just going to skip ahead in my so the retarded contribution of the electron to the solenoid vanishes due to space-like separation, while the advanced contribution of the solenoid as this quantum non-local remains non-zero. Crucially, the two contributions are additive rather than subtractive. There is no antisymmetry that could produce cancellation. The symmetrized structure of the propagator therefore enforces a non-vanishing result. And why is it non-vanishing? Because a finite spacetime region remains in which the two particle currents differ. It is precisely this region that contributes to the phase. Since there is no corresponding region with an opposite sign or symmetry to cancel it, the remaining contribution survives. The non-zero phase is therefore not an artifact of incomplete path subtraction, but rather persists because the cancellation has been properly implemented. So again, what this means is that because of relativistic forward causal disconnect, what they're calling the forward causal disconnect regime, because of the symmetry in the quantum amplitude, you are forced to cancel out the effect of the electron on the solenoid as a retarded phase, a retarded influence. But you're not forced to subtract the time reverse advanced influence of the solenoid on the quantum diffraction, and therefore this proves that there is a quantum non-local future force that's affecting the phase of the diffraction of the electron. So a natural suspicion is that the advanced and retarded components of the Feynman propagator might cancel in the delayed switch configuration, yielding a vanishing phase. However, this does not occur. The coherent sum of two physically distinct but mathematically equivalent processes occurs in this observable Aronoff-Bohm phase in the delayed switch experiment. So the real part governs the relative phase between interfering histories. In the forward causal disconnect regime, the retarded contribution vanishes due to space-like separation, as I already read this part. So there is no corresponding region with an opposite sign or symmetry to cancel it. In other words, it's asymmetric or non-commutative. There exists no principle within quantum electrodynamics requiring interaction terms to vanish for space-like separated finite duration couplings at the level of amplitudes. The in-out formalism computes transition amplitudes between asymmetric states, asymptotic states, whereas experimentally accessible quantities are expectation values of observables at finite times. So there's a difference between the transition amplitudes, and this was Basil J. Haley's big point, that the Feynman transition amplitudes are actually the non-commutative quantum potential. The in-out framework permits time-symmetric correlations at the level of amplitudes, whereas the in-in framework enforces microcausality at the level of expectation values. So again, you have this disconnect between what causality would predict versus what you actually observe in the quantum phase change at the detector. The effect provides a sharp, so in other words, the future is changing the past due to the quantum potential of the solenoid. This effect provides a sharp diagnostic of the conceptual foundations of quantum electrodynamics, isolating the interplay between time-symmetric amplitudes and time asymmetric causality conditions. So this was the whole point of Olivier Costa de Beauregard's book, the magnitude of time, and it's all about this whole paradox, what this experiment isolates. So what the phase that contributes to the quantum amplitude but does not correspond to a classically advanced field that can be directly measured locally. The phase shift is a global topological effect. Even when the local field is zero, the phase is gauge invariant. So if the advanced influence were a classically advanced field, as per it would be locally detectable and could in principle transmit information backward in time, violating relativistic causality. So the as I mentioned before, the commutator vanishes for space-like separation. The phase is read out only after the solenoid has been switched on. So the effect is coherent and non-local. It modifies the interference pattern, but cannot be used to send a superluminal message. Now, of course, this is different than quantum biology, because in quantum biology, you're able to maintain this asymmetric non-locality from the future as a force that self-amplifies into the macro scale due to the non-commutativity, and that was Basil J. Haley's big point. So a virtual photon connects the electron to the solenoid in a time-reversed manner. Such histories are not, quote, real in the classical sense, but are an essential part of the quantum superposition that yields the observable phase. So in this case of space-based non-commutativity, it does not vanish at space-like separation in the non-commutating directions. I'm actually at this point I'm quoting other related studies. So the star commutator fails to vanish even in the space-like wedge, relativistic wedge, and completely violates causality. The causality principle and the spectral condition are in conflict. So the spectral condition comes into conflict with causality, as is evident from the foregoing. So by spectral, they mean time frequency. So you have this negative frequency as a virtual photon. So this is precisely an experiment that corroborates in detail what I've been talking about this negative frequency virtual photon non-commutativity that's also non-local. And then there's another paper that says why the retro causality that Jack Safari promotes doesn't work, because it depends on a wavelength with a future boundary condition that violates the fact that it cannot be localized in the past. So again, that's the same problem where you can't have the electron have a retarded localized effect in the past. So Bell's non-locality cannot be explained by retrocausality. And then this study says the choice of reference frame is not merely conventional, but physical, consequential for causal explanations. So that directly gets into philosophy of meditation. Like, what is your reference frame when you're meditating, essentially? The commutator fails to vanish at equal times, and thus fails to obey microcausality at space-like separation. This form of non-commutative field theory fails to obey microcausality in general. Yeah, so this is like really wild stuff because it's very, very radical. To essentially, you're disproving relativity as the foundation of reality, and that's going to piss off like 99% of physicists. And that's pretty much all I have to say.